Hello and welcome to my video. Today I'm going to explain what is a convolution neural networks. Basically, convolution neural networks is a variant of multi-layer perception or a artificial neural networks. So what makes this different from a artificial neural networks? Because it contains some convolution layers that actually detects patterns, features from an image. Basically, networks mostly used for image classification, but can also be used for data analysis and classification of different kind of data. So let's see a simple overview of a convolution neural networks, or also known as CNN or a convent. So here you can see there is basically uh, two main part of a convolution neural networks. So these four layers we can see these layers are convolution layers, and these layers are fully connected layer. We can see that, and firstly we can see a input image. It is an image from MNIST dataset. MNIST dataset contains handwritten digit from 0 to 9 images with a pixel size of 28 by 28. So uh, firstly, we're going to see a overview of how convolution neural networks work, and next we are going to see how a convolution happens on a pixel of images. So these convolution layers actually detects patterns and features from an image. Then it passes it to the fully connected layers, and fully connected layers is actually artificial neural networks. Fully connected networks actually classify the image into our desired classes. Like in image, as I said, there is 10 classes of images from 0 to 9, handwritten images of 0 to 9 digits. So there is 10 class. So how many class do we have? 10 class. So we're gonna have a the last layer, the output layer will have 10 nodes. So firstly, what happens, it takes the image, then it extracts features or patterns from the image, and it passes it to the uh, deep fully connected layers. So before that, to pass this convolutional output of the convolutional layer to the fully connected layer, we have to flatten the output of convolution layer so it can be fed into the fully connected layers. As you can see, there is just one hidden layers, uh, but a fully connected layer contains thousands or hundreds of hidden layers, and the output layer, as I have said, will contain number of nodes. The nodes of the output layer will contain the number of classes we want to classify. So this is the basic structure of a convolution neural network. So whenever here we can see only two convolution layers followed by a max pooling layer. So we're going to get into that in a bit. So here you can see we have a this is the first convolution layer. It contains a filter of 5 by 5. Filter is also known as a kernel. So the filter could be a 3 by 3 filter or a 2 by 2 filter, 5 by 5 filter. It doesn't matter. It will have to define it depending on your data set. So there is only just two convolution layers, but we can add thousands of hundreds of convolution layer neural networks. So each time we use a convolution layer, we have to define number of filters and the filter size or kernel size. And here you can see the kernel size is 5 by 5. And each time we use a convolution layer, it will be must be followed by a max pooling layer. So we're gonna talk about max pooling layer in just a moment. So we're gonna come back to the image. Let's first have a look how a convolution works. So we know that images are represented in multidimensional arrays, or sometimes called tensors. So this is a simple representation of an image. This is not representation of a mnist image, but for a simple demonstration purpose, I have taken this image. Just consider it as a multi-dimensional array, and it contains pixel values. Just imagine this is a representation of an image in a multi-dimensional array, or sometimes it's called tensors, right? And then let's consider we have a 2 by 2 filters. 2 by 2 filters, and the operation is very simple. We just uh, slide these filters over this image, input image, each 2 by 2 block of the input image, as we have a filter of 2 by 2 size. So if we had a filter of 5 by 5 size, we had a slide over each 5 by 5 block of our input image until we finish all 5 by 5 blocks. So here we have just only 2 by 2 filters, so we will slide this 2 by 2 filters over starting from this 2 by 2 block until this 2 by 2 block. So basically we're going to slide over the input image. We're going to slide the filter 2 by 2 filter over the input image until it finishes, until it reaches the last 2 by 2 block of input image. So as we slide over, um, as we can see, when we slide over this yellow 2 by 2 block, we'll perform a dot product, and we'll sum the products, and we'll store the value in this place. And this is how a convolution works. So if we perform a dot product with this 2 by 2 block, we'll get an output of 2. So this array or multi-dimensional array gives us a whole new representation of an input image. So this kind of operation, this kind of convolution, the sliding over of an input image, is called convolution. So this kind of convolution happens at every convolution layer, and this is how convolution works. So when an image passes through hundreds of convolution layers, so we would be able to detect many complex features, complex patterns. A pattern could be a circle or edges, many different things. So another thing we have say we have used for max pooling. Max pooling is basically used to reduce the dimensionality of input image. So the computational time decreases, the cost decreases. So it helps us to reduce the computation time of a model. So the basic idea here is we use a max pooling, 2 by 2 max pooling with a stride 2. So here we it's just like a filtering. We have just take first 2 by 2 block, and we uh, first 2 by 2 block, and we select the maximum number containing in that block. So maximum number in this red block is 2, so we place 2, we store 2 here, and we stride over two two columns in the images to the next 2 by 2 2 by 2 block. So this is how it works. The next 2 by 2 blocks, 4 is the maximum number, and we store 4 here. This is how max pooling helps us to reduce the dimensionality, so we can reduce the computational time of a model. So let's go back to the main images. So let's have a last overview. So we have two layers, a convolution layers and a artificial neural networks layers, also known as fully connected layers. And so here is the input. We're giving an image as input, and this image is convolves across this convolution layers. And as I have said already, it may contain a one or more, or a thousand and hundreds of convolution neural networks. Then we flatten the inputs so we can fade into the fully connected layers. And as I have said earlier, fully connected layer may contain hundreds or thousands of convolution neural network depending on the dataset we are using. So, and the output layer will contain number of nodes, same as the number of classes of images when we classify. So this is the simple overview of convolution neural networks, and thank you for watching. Thank you.